Okay, so in this video we're looking at chapter 3 and number 3 specifically um, on the final review. Here we have a polynomial. It's a rather large one. It is degree 6. Um, and what we're trying to do here is we want to first determine possible rational roots. So we're determining all possible rational roots using our rational zero theorem. And that's the one that is the P over Q, if you remember that. So let's start with that. Okay. So if you remember, the rational roots of the polynomial are going to be a fraction of numbers, right? That's what rational is. And the top ones are factors of the of this constant right here, this 12. In our case, it would be 12, okay? And then the bottom ones are factors of the leading term, so 2 in this case. So P, the things that P can be are, well, factors of 12. What goes into 12? Well, 1 does, and I'm saying plus or minus for all of these, right? Because negative numbers work just as well as positive when you're going into 12. 2 will go in there. 3 goes in there. 4 goes in there. 5 doesn't, so we don't need that one. 6 does. 7, 8, no. 9, no. 10, 11, 12. Yeah, so these are all the numbers that go into, oh, sorry. We also need 12, right? Those are all the numbers that go into 12, the factors of 12. Okay? Q, that can be any factor of 2. So really, I mean, they could be pluses or minuses, but if you put pluses and minuses on P, you don't need to worry about them on Q. So the things that go into 2 are 1 and 2, right? Those are the only things that go in there. So the possible rational roots that we have are just the fractions, all possible combinations of these p's divided by these q's. Okay, so my rational roots are going to be, well, when I divide the p's by 1, right? Dividing by 1 doesn't change anything, so we're going to get all those same numbers again. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay. Gonna get all those same numbers again, and we're also gonna get the ones where we divide by 2. So what does that add to things? When I take plus or minus 1, divide it by 2, I get plus or minus 1/2. And also, and again, these are possible, these aren't necessarily the roots, but possible rational roots. When I divide 2 by 2, I get 1. We've already got 1 taken care of. I divide 3 by 2, and I get 3/2. So we got plus or minus 3/2 will flow over here, okay? 4 divided by 2 is 2. We've already got 2 taken care of. 6 divided by 2 is 3. We've already got 3 taken care of. 12 divided by 2 is 6. We've already got that taken care of. So these are the all the possible rational roots. You can see there's actually quite a few of them, right? There's 1, 2, 3, 4, 5, 6, 7, 8 times 2, so 16 total possible rational roots for this polynomial. And so what we're going to do now is we're going to start trying to find a root of this polynomial. We would really like to, what we're going to be doing on this is, for part B, we're going to be factoring the polynomial. Okay, so we're going to factor this polynomial. So to factor it, I need to find the roots, right? And so what I usually do with this is I take and I plug in these numbers until I find one that will give me 0, right? Roots are where the polynomial equals 0. What numbers can you plug in and get 0? So let's plug in +1 and see if that works. Well, we get 2 minus 1 is 1, minus 13 is -11. Maybe I'll keep track of this over. -11 so far, and then plus 13, plus 19, minus 32, plus 12. And I'm not sure if that's going to work. This would give us 2 plus 19 plus 12 minus 32. These two is going to make 31. This is going to be 33 minus 32. So that is so close to working, but it's not quite there. Unfortunately, wait, I made a mistake. Sorry. On this, when I plug in 1, I get 2 minus 1 is 1, and then minus 13, that's -12. Okay, that threw us off. So get 1. Yes. So when we add those two, we get 32. All of these, yeah, so this is actually 0. When I plug in 1, I actually got 0, which is great. That we already found one, which is awesome. So now that I know 1 is going to work, I'm going to do my synthetic division on it. So 1 we know is a 0 of this, so then I put the coefficients up here. 2, -1, -13, 13, 19, -32. Oh my gosh, this is a huge problem. Okay, let's do this. So 2, -1, -13, 13, 19, -32. 12. Isn't this just beautiful? I picked the hardest one to do in this video so that you wouldn't have to do it. Okay, so I'm going to bring down my 2, right? And then I times these two, so times those together we get 2. Then we add these, we get 1, times them 1, -12 times 1 is -12, plus is 1, times is 1, and then add, we get 20, and then 20 here is -12. Okay, times 1 is -12, and then when we add those we get 0. Okay, so this is just great. So what have we done so far? We've been able to factor out an x minus 1 essentially, and this is the other thing. This like 2, it would be 2x to the 5th now, and then 1x to the 4th minus 12x cubed, right? this, we'd just do x minus 1 times this polynomial to give us that polynomial. So we factored out a 1, okay? So now we want to do kind of a similar thing and find if other roots so that we can keep factoring them out, right? There should be 6 roots. Maybe not all of them are real, but or rational, but there should be 6 in the end. So let's go ahead and keep going here. So we got rid of our root of 1. We know that that worked. So let's maybe try negative 1. So, and I'm just going to plug it into the smaller polynomial that we have now. The smaller polynomial we're really dealing with here is we're doing 2x to the 5th plus x to the 4th minus 12x cubed plus x squared plus 20x minus 12, right? That's what this polynomial is, and we're just timesing it by x minus 1 to get the original polynomial. So let's try plugging in negative 1 into that guy and see what happens. So we get negative 2. That would give us negative 2. This would give us 1. This guy, when I replace it with negative, would switch. Well, cubing a negative gives you a negative, times a negative will be a positive. A negative squared is a positive, and minus a negative 20x minus 12. Okay. So is that going to be 0? I hope so. That would be nice. Those two cancel. Oh, no, there's no way. Yeah, that's not going to be 0. So negative 1 does not work. That was worth a try. Okay. So let's go ahead and times and plug in our next root, which is our possible roots are plus and minus 2. Okay. So what can we do with that? Oh, this is going to be terrible. Okay, so negative 1 didn't work on this one. And so actually what I'm going to do here is, if you notice with this, when we factored out this 1, these coefficients, the 2 and the negative 12, didn't change at all. So the possible rational roots for this polynomial are the same as the rational roots that we had for here. So I tried negative 1 and it didn't work, but let's go back and try positive 1 as well. So I'm going to plug in positive 1 again and see if it works. So we've got 2 plus 1 minus 12 plus 1 plus 20 minus 12. Okay, so is that going to be 0? Well, we've got the positives. We've got 2, 3, 4 plus 20 is 24. The negatives, we've got 2 negative 12, so minus 24. So again, we've got 0 here. Okay. So yes, this is 0 when we plug in 1. So again, I'm going to use the same factor here. So in other words, there was repeated roots here. There was 2 factors of x minus 1 in there at least. Okay, so we're going to do 2, 1, negative 12, 1, 20, negative 12. Okay, so we're factoring it out of this polynomial now. Okay, so we bring down our 2 times by 1, 2, so 3, times by 1 is 3. Add is -9 times 1 is -9. -8 times 1 is -8. Add is 12 times 1 is 12. There we go. So 0 again. So far we've factored out two x minus 1s, right? So there's going to be an x minus 1 squared in there for sure. So now we're going to look at factoring this bad boy. Okay, so like this will have it was an x to the 5th, so now it's going to go down to an x to the 4th plus, and then we've got 3x cubed minus 9x squared minus 8x and then plus 12. Okay, so that's the new polynomial we're dealing with. So again, since we should start probably with 1 again and just check, is 1 a root of this new polynomial when we divide it out twice? Is there another 1 as a root of this? So when we plug in 1, we get 2 plus 3 minus 9 minus 8 plus 12. So minus 17. And 2 plus 3 is 5 plus 12 is, oh my goodness, it's 17 again. Okay, so this is actually 0 again at 1. So we're going to do it again. We're going to factor out another x minus 1 from all of this. So we've got 2, 3, -9, -8, 12. Okay, so bring down the 2. Times by 1 is, add those, 5. Times by 1 is 5, -4. And times by 1 is -12. So, oh my gosh, isn't that just fun? Okay, so I'm going to move this for a sec. So far we've factored out 3x minus 1s from this polynomial. So is there anything else we can factor? So the polynomial I'm left with now that needs to be factored is 2x, well it was a 4th before, so now it's a cubed, plus 5x squared minus 4x minus 12. Okay, we should probably check here that there's not another 1 in here. So if I plug in 1, I get 2 plus 5 is 7. Minus 4 is 3, and then minus 12, that's not going to be 0. So that's all the 1s that we're going to have in here, all the x minus 1s as our factors. Okay, so now we just need to factor this cubic, and let's maybe try -1. Well, we had already tried -1 before on the other polynomial, and that didn't work. So that is not a root at all. Okay, but if we kind of look back at our list just for a sec. So we've got all the 1s, we've got that, we knew -1 didn't work. So let's try 2 next on this cubic that we have here. Let's try 2 and see if it works. So we're going to get 2 times 2 cubed plus 5 times 2 squared minus 4 times 2 minus 12. So we've got, let's see, 8 times 2 is 16 plus 5 times 4 is 20. And then minus 8 and minus 12. So those two will cancel out, but we're left with 16. So that's not 0. So 2 doesn't work. Positive 2 doesn't work. So let's try -2 then. So 2 times -2 cubed is -8 plus 5x squared, so negative 2 squared is 4 still, so it's 20. And then minus 4 times negative 2 is going to be plus 8, and then minus 12. So what have we got here? We're going to have negative 16 plus 28 minus 12. And oh hey, that is 0. Okay, so this works. Negative 2 works, okay, which is great. So now let's do our synthetic division. Negative 2. Okay. On this polynomial, so 2, 5, negative 4, negative 12. Okay, so we're going to bring down our 2, then we times by negative 2, we get negative 4, 1, so negative 6, and then times is 12, and then 0. Okay. Whoa. Isn't that just the funnest? Okay. So we now are at a very nice point of our process. We are at a quadratic. We've got 2x squared plus x minus 6. This is our polynomial we're ended up with. So far we know there's a repeated root of 1 3 times. There's a negative 2 as a root. Well, to factor this guy, you could use the methods that we have for factoring quadratics to do this. I'm just going to keep plugging in things and try and find a root. So where we had used negative 2 before, let's see if negative 2 works in this again to see if we have a repeated root. So when I do negative 2 again, I'm going to get, okay, so we get 4 times 2 is 8, minus 2 minus 6, oh hey, that is 0. Great. So negative 2 is another root. There's a lot of repeated roots in this one, right? Okay, so negative 2, we bring down our numbers here. So 2 times negative 2 is negative 4. Add those is negative 3 times 2 is 6, so 0. Okay. And now we have it completely factored in that we have this factor here is linear, right? It's a 2x minus 3. Okay. So what does that tell me the factored form is? Well, I was able to factor out x minus 1 3 times, right? So there's going to be, my factored form is x minus 1 cubed, x minus 1 times itself 3 times. And then we were able to factor out the negative 2 twice. So that's going to be x plus 2 would be the root there, where the factor there would give me a root of negative 2. That's going to be squared because we were able to do it twice. And then my remaining factor is going to be 2x minus 3. So this will be my factored form of this polynomial. And this was extremely nasty. So hopefully you're glad that I did this one for you. Okay? Now, last thing I want to do here before we're done is we'll do one more kind of problem. C from this is, let's sketch a graph of what this is going to look like. So let's sketch a graph showing intercepts and end behavior. So the function that we're dealing with is this in factored form, right? And so the x-intercepts of this graph, those happen. The x-intercepts are the ones that happen where y is 0. So my x-intercepts here are +1, -2, just switching the signs on those. And then this last one, the 2x minus 3, to solve for where it is 0, we say that's equal to 0, and then we add over 3, and then divide by 2. So 3/2. So those are the 3 x-intercepts. The y-intercept happens when x equals 0, right? So that's going to be, we plug in 0 for x, we get -1 times, well, 0 plus 2 is 2, so 2 squared, 0 minus 3, so -3. So we've got 4 times -1 is -4, times -3 is 12. So 0, 12 is our y-intercept. Okay. The end behavior of this graph is going to, let's look at our original equation before we had it all factored out. This was the same thing as 2x to the 6th minus x to the 5th minus 13 x to the 4th plus 13. You don't need all this. Anyway, it kept going. Okay. The end behavior here is really only determined by this first term, right? That's the one that dominates the other stuff. So when you plug in a really large number in for x, like a really large positive number, you raise it to the 6th power, it's still going to be positive. Times it by 2, it's still going to be positive. So it's going up to infinity on the right. So as x goes to infinity, y also goes to infinity. And then as x goes to -infinity, so a really large negative number, you take a really big negative number, raise it to the 6th power, you're going to get a positive number. Times 2 is going to be a positive number. So y is going to go to positive infinity. Okay. So what is our graph going to look like? We're going to be at 1, 0, we have a 0. At -2, we've got a 0. At 3/2, so that's 1.5, we have a 0. Okay. And then the y-intercept here is at 12, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, hopefully the one they give you on the test won't be as nasty as this. This one's terrible. Okay. And then the multiplicities on these tell you kind of what the graph looks like near there. So where I'm at -2, I have a multiplicity of 2. So that's even. So it's going to curve around. And it's going to just touch there and go back up, right? Oop. Okay. And then at +1, this has a power of 3 on it, so it's going to go through. I don't know exactly what this looks like, but sketching here just goes straight through. And then 2x minus 3 has a power of 1, so it goes straight through as well. So that would be what our graph would kind of look like there. Okay. Whew, this is such a process. So I did the hardest one for you, and we'll look at a few other problems in this section to kind of make sure you're ready for the exam.